right, so section 11.5 is the last section for this class and the last section of this chapter that we'll be covering. So this is going to be kind of an application section based on the quadratic equations we've been talking about. First thing we're going to do is solve for specified variables. And so this is stuff that we've seen before. So when you're given an equation that has several variables in it and you're told to solve for a specific one, we have seen this. We saw this with radicals. We've seen this back in Math 95. Now we're going to see it where you have something being squared. And so we'll just look at one of these because a lot of these are really similar. So we're told to solve, and I put examples. It's really just example. We're given n equals ab all over e squared. We're told to solve this for e. I'm so sorry, this is not the one that I meant to write down. All right, same kind of question. So we're still solving, but we are going to solve s equals pi r squared h for r. All right, this is the one I meant to write down. Let me move this 4 over a little bit so it doesn't look like it's part of the equation. All right, so we're solving this for r. And now our goal is to get this by itself. And so you want to see what you want to get rid of. First thing we want to do before we get rid of the square, because remember the opposite of squaring something is a square root. But if I square root right now, we have to do this entire side. And I don't want to end up with the square root of pi and h over here. So we won't do that quite yet. First thing we want to do is get rid of this, the pi and the h, because those are both on the right side and we do not want them over there. So pi and h are both being multiplied by r squared. So I'm going to divide both sides by pi h. Now we can do it in one step because they're both multiplication. And if you notice on this side, pi and h cancel. So we're left with an r squared. And over here, it looks ugly, but you're going to leave it as s over pi h. All right, we are super close to being done. The last thing here is we want to get rid of the square on the r squared. So we're going to square root both sides. And so a couple things that they're going to tell you. They will tell you to leave the plus and minus in your answer. They're also going to tell you to rationalize all denominators. So what we're going to do, this side is just an r. Let's go ahead and first split this up. So I'll leave plus and minus in the front. Remember, with your square root property, you always put plus or minus. Now on the top, we're going to have the square root of s. And on the bottom, we have the square root of pi h. Just went ahead and split that up. Now, I'm going to go ahead and rationalize off to the side, and I'll ignore the plus or minus because that's just going to stay in the front. So this is to rationalize. Remember, when you're rationalizing, we do not like to have radicals in the denominator because this tells us how many pieces we have in the whole of our fraction, and we can't have fractional pieces in the whole, only on the top. So we're going to multiply the top and the bottom by whatever radical we have in the denominator. So in this case, it's a pi h. So on the top, we have an s pi h. These are all different variables. Well, pi is a number, but they're all different. So we're just going to go ahead and combine them into one. So s times pi times h, s pi h. And the order technically doesn't matter if you wanted to do it exactly right. The pi would go in the front because pi is a number. Numbers always go in the front. But I'm just going to leave it as s pi h. Now, on the bottom, we have the square root of pi h times the square root of pi h. Remember the shortcut, those square roots disappear, and we just get pi h. Now, this is already completely simplified because we cannot cancel out the pi and the h because the ones on top are under a radical, the ones on the bottom are not. So our final answer is plus or minus the square root of s pi h all over pi h. So two different answers if you wanted to split this up like my math up sometimes once. You're going to have positive square root of s pi h over pi h and negative square root of s pi h over pi h. Okay, so that's one type of question you'll see where you want to get the variable, solve for a specific variable, I should say. So now let's go ahead and look at the start to our word problems. So before we get to actually doing those word problems, we do need to take a look at one thing which we've seen a little bit before, but I want to review. This is the Pythagorean theorem. And we're going to use this quite a lot in this section, actually, because if you remember, the Pythagorean theorem has some squares in it. So it's kind of like a quadratic equation in that sense. The Pythagorean theorem, let me see if there's no triangle I can use. All right, we're just going to draw our best triangle. You have a right triangle. And so this angle right here is a right angle, so it's 90 degrees. And then we're given three sides, A, B, and C. C is the hypotenuse, A and B are the two legs. Doesn't matter which one A or B is, but C has to be the hypotenuse. So our Pythagorean theorem says if we square the two legs and add them, so A squared plus B squared, we get the hypotenuse squared. And this is true for any right triangle. No matter what, if you square the two legs and add them, you will get the hypotenuse squared. So let me write this in here. These are the legs, and this is the hypotenuse. All right, so our first example here, I'm going to go through a few of these. So number one, we're given a right triangle. And we're given the two legs are M and N, and the hypotenuse is P. And we're told to solve, we'll do it here. Solve for N in terms of the other variables. All right, so we know we're solving for N. And all they give us is this one drawing. So one thing you should notice is that this drawing is just a right triangle with three sides labeled. We can use the Pythagorean theorem. So I'm going to fill this in. Our legs are M and N. So I'll just put it in alphabetical order. So M squared plus N squared equals P squared. And then we want to go ahead and solve this equation for N. So in order to do that, first thing we want to do is get the N term by itself. So this term right here. So we want to move this M squared over to the other side. So let's subtract that. We get N squared equals, now I'm going to put this at the end. So we'll have P squared minus M squared. They're not like terms, so you can't actually combine them. And now our next step to get this N by itself, we want to square root both sides. Now remember, when you're using the square root property, you want to put that plus or minus on the right. So if I go ahead and do this, the square root of n squared is n. And now remember that you cannot take the square root of this p and the m squared separately because of this subtraction in the middle. We're going to keep it just like this. So it's ugly, but it's what our answer is going to look like. But one other thing to keep in mind here, and this happens a lot when you work on application problems, since we're talking about the length of the side of a triangle, we cannot have negative length. So we're going to disregard this negative here in the plus or minus. And so n is just going to be equal to positive square root of p squared minus m squared. So make sure in application problems you pay attention to what works and what doesn't in terms of your final answers. All right, so let's go ahead and try another one. And this one I'm actually going to write up or type up. I think it'll be a little bit faster than me trying to write it all. So we're told, let me actually change the color. There we go. So two ships leave at the same time. One goes south, the other east. Several hours later, they are 170 miles apart. If the ship going south traveled 70 miles further than the other, how many miles did they each travel? Okay, so we have two ships leaving at the same time. And so sometimes ones like these, they'll give you a drawing, and I think they actually do give you the drawing for this one. But let's go ahead and kind of talk through it just in case they don't. So we have two ships leaving at the same time. They're also leaving from the same place, which let me add that in here if I can. Okay, so it's not gonna let me put this in the same box. That is not what I wanted to do. Sorry, 1 second. There we go. So they're leaving at the same time from the same port. So let's say they're leaving from right here. Now, one goes south, so one is going this direction. One is going east, so one is going this direction. And several hours later, we know they are 170 miles apart. Now, that distance is a straight shot from where those two ships are. Let's say we have one of our ships over here, a straw little boat, and then one of our others is over here. This is going to be 170 miles. Now, we know the ship going south traveled 70 miles further. I cannot type. I should have checked this. 70 miles further than the other. So let's say the ship going to the right, this is just a hypothetical. Let's say it went 10 miles. If the one going south went 70 miles further, we would add 70 miles to that. But we don't know how many, oh my goodness, how many miles they're like overlapping. So it's gonna trying to erase them. We don't know how many miles the ship going to the east went. So let's call that X, but we know the one going south went 70 miles further. So this one is going to be X plus 70. Now, I believe they give you this drawing. If not, this is going to be how you want to set it up. You might just have like north and west instead of south and east. Once that is set up, if you notice, we have a right triangle because south and east are perpendicular directions. So we can go ahead and use the Pythagorean theorem. So we're going to have our two legs. We're going to have x squared. Let me rewrite our Pythagorean theorem up here. So x squared plus x plus 70 squared. So make sure you square that entire quantity equals the hypotenuse squared, which is 170 squared. All right, now some big numbers to work with, but it's not going to be terrible. So if we go ahead and square each one of these, we have x squared, that one just stays as is, plus, now I'm going to write this out as x plus 70 times x plus 70 equals 170 squared. For ones like these, you can write this out and do the multiplication. For the sake of time, I'm going to tell you that this is 28,900. Now, if we go ahead and multiply this together, we have x squared plus, now x times x is x squared. X times 70 is 70x. Again, in the middle, we have another 70x. And 70 times 70, 7 times 7 is 49, and add the 2 zeros. Now, let's go ahead and simplify this and get it set equal to 0 because we have a quadratic equation. So x squared plus x squared is 2x squared plus 70 plus 70 is 140x. Plus 4,900 equals 28,900. Now I want to make this equal to 0, so I'm going to go ahead and subtract 28,900 over to the left. Works out pretty nicely because those 900s cancel, so we're going to have 2x squared plus 140x plus 4,000 minus 28,000, because those 900s are gone. We're going to have a negative, so subtract that, put a minus 24,000 equals 0. Now, if you notice, this is something we didn't see back in 11.3 when we were doing the quadratic equation or any of the others. These are all divisible by 2, 240 and 24,000. So in order to work with smaller numbers, what I'm actually going to do is I'm going to divide every single term by 2. Now, this is something you can do as long as every single term is divisible by that number, which it is. We have an x squared now, plus half of 140 is 70x. Half of 24,000 is 12,000 equals 0. So now we have our quadratic equation here. Couple ways you could solve this. You could try to factor if you wanted. If we had to factor, or if we wanted to factor, we would find two numbers that multiply to a negative 12,000 and add up to 70. Now, if we started going through the factors of 12,000, we'd have 2 and 6,000. I'm skipping the 1 and 12,000 because that's not going to help us. In this one, 3 is going to go into it because 3 goes into 12 4,000 times. 5 is going to go into it, but if you notice how far apart these numbers are right now, we want them to have a difference of 70. So let's try doing something a little bit bigger. Let's try doing, let's do 30. So 3 goes into it 4,000 times, so 30 is going to go into it 400 times. Getting a little bit closer, but this is still going to take us a while. So instead of going through and doing that, this is one of those times where factoring might be possible, and these numbers are pretty nice round numbers. I would assume that it's probably factorable, but I don't want to have to go through that list and find those two numbers, especially without a calculator. So let's go ahead and do the quadratic formula. So x equals negative b, negative, let me write these out, a, b, and c. A is 1, b is 70, c is negative 12,000. So we are going to have to deal with that big number, but let's go ahead and try it. So x equals negative b, so negative 70, plus or minus the square root of b squared, so we're going to have 70 squared, minus 4 times a, which is 1, times C is negative 12,000. That is going to be a big number, but maybe it won't be too bad. We'll see. All over 2 times A. So 2 times 1. Now let's go ahead and try simplifying this. We're going to have negative 70. Let me see where I'll have the most room for this. We'll do it down here. Negative 70 plus or minus the square root of, now 70 squared, 70 times 70 is going to be 7 times 7 is 49. Add those 2 zeros. Minus, and there's a negative, so it'll be a plus, 4 times 12,000. Now, 4 times 12 is 48. Add the 1,000. Really big numbers here, but we'll see what they're like. 2 times 1 is 2. All right, so now what we want to do is we want to go ahead and combine these two numbers together on the inside. So negative 70 plus or minus the square root of 48,000 plus 4,000 is 52,000. So 52,900 all over 2. So this is one of those square roots where it's really big. You probably don't know the square root of 52,900, but let's go ahead and look at this kind of off to the side. So we have the square root of 52,900. Now, one thing I'm going to notice is that it has a 100 at the end. So what I'm going to actually do is split this into 529 times 100. Now, the reason why I did that is because I know the square root of 100. So we can take whatever 529 is, the square root of that, and multiply it by the square root of 100. So let me go ahead and actually just split those up, just so you can kind of see what I'm talking about here. So we're going to have something here times square root of 100, which is 10. Now, square root of 529, smaller number to work with. 529 is bigger than 400. So I know 20 squared, 20 times 20 is 400, but 30 squared is 900. So it has to be a little bit closer to 20, and it has to be between 20 and 30. Another clue you can use here is that it ends in a 9. To get a 9, we need a 3 times 3. The other option would be 7 times 7, because that's a 49. But we want to say it's closer to 20 because 529 is closer to 400. So I'm going to try 23 times 23. If you weren't sure which one it's closer to, you can just kind of multiply and guess. But you've kind of narrowed it down to between 20 and 30. 3 times 3 is 9. 3 times 2 is 6. 2 times 3 is 6. 2 times 2 is 4. So we have a 9, 2, 5. 529. So the square root of 529 is 23. And 23 times 10, add the 0, you get 230. So negative 70 plus or minus 230 over 2. Now, we have two different answers here, but only one will work. We're going to have negative 70 plus 230 over 2. And negative 70 minus 230 over 2. Now, if we go ahead and look at this first one, negative 70 plus 230, if we go ahead and subtract those, we get 160 over 2, which is going to give us 80. And now if we look at this other one, negative 70 minus 230 is negative 300 over 2. Well, that's a negative 150. Oh, and it doesn't squeeze on the end there. Sorry, I'm trying to squeeze this over here. Negative 150. So we're talking about distance here. This is x, which is our distance going east We cannot have negative distance. So you want to disregard any negative answers, only focus on the positive ones, which is 80. Now, if we go back over here and let me do this in a different color, we want to know how many miles did they each travel. So the ship going east, and then we have the ship going south. The one going east was X. So X is 80. So the one going east is 80. That was X. And the one going south is X plus 70. So we're going to take 80 miles plus 70 is 150 miles. So that's 80 plus 70. All right, so these are our solutions. And so this one is kind of a mess. The numbers are really big. Not all of the numbers for these problems are going to be as big as these. This was kind of like you saw the rough one first, and it should only get better from here. So let's go ahead and look at number 3. And we'll get a new page. So number 3, I'm going to go ahead and type this out again. Hopefully I type it without any mistakes this time. Jennifer is planting a garden in the shape of a right triangle. She just really likes triangles. All right. So the longer leg is 3 feet longer than the shorter leg. The hypotenuse is 3 feet longer than the longer leg. Find the lengths of the 3 sides of the garden. Okay. So first things first, I like to draw out pictures for these. Pictures are really helpful when you're dealing with any kind of geometry type stuff. In this case, we're looking at triangle. So we know we have a right triangle garden. We know that we have a longer leg and a shorter leg and the hypotenuse. Now, we know the longer leg is 3 feet longer than the shorter leg. Just using this information here, if I call the shorter leg, we'll call it S. The longer leg is going to be 3 feet longer. So it's going to be the length of S plus 3. And then it says the hypotenuse is 3 feet longer than the longer leg. Well, now if I take our expression for the longer leg, which is S plus 3, and add 3 again, that's going to be the length of the hypotenuse. So I'm just going to simplify this to S plus 6. So this is the longer leg, the shorter leg, and of course the hypotenuse. Okay, now that we have our 3 expressions set up, we have S plus 3, S, and S plus 6. We can go ahead and set up our equation. We know that we have our Pythagorean theorem, so a squared plus b squared equals c squared. So a squared, we're going to have one of our legs squared. I'll start with s plus 3 squared plus b squared, so s squared, equals c squared, so s plus 6 squared. Now, if I go ahead and multiply these guys out, we're going to have s plus 3 times s plus 3 plus s squared. And then we'll have s plus 6 times s plus 6. Now let's go ahead and multiply. So s times s is s squared. S times 3 is 3s. 3 times s is also 3s. And 3 times 3 is 9, so plus 9. Plus s squared. Don't forget to bring this guy along. It's really easy to kind of forget those. And then on the right side here, s times s is s squared. S times 6 is 6s. Same with the inside terms, another 6s. And 6 times 6 is 36. Now, before I start moving things around, I'm going to go ahead and simplify. So on the left here, we have s squared plus s squared is 2s squared. 3s plus 3s is 6s. And then we have plus 9 equals, now on the right side, we just have 1s squared. 6s plus 6x is 6s is 12s plus 36. Now, if I go ahead and get everything on one side because we have a quadratic equation, I'm going to put everything on the left so that the s squared stay positive. So I'm going to subtract s squared. Okay, I'll do this in multiple steps just so it doesn't look too messy. So we're going to have 1s squared plus 6s plus 9 equals 12s plus 36. Now I'll move the 12s over. So we have s squared minus 6s plus 9 equals 36. Then I'll move the 36 over. So again, you could have done this in one step, whichever you're more comfortable doing. So s squared minus 6s, 9 minus 36 is going to be a negative 27 equals 0. Now, before we go to the quadratic formula for this one, I'm going to check to see if it's factorable because these numbers are nice and small. So factoring is definitely doable. We just want to make sure that it's not factorable before we go to the quadratic formula, because quadratic formula for one like this is going to be, I'm not going to say pointless because you'd still get the answer, but it is going to be a lot longer to go through and do all of the steps rather than just factoring. So we're multiplying to negative 27, adding to negative 6. The factors of 27, we have 1 and 27. And remember, we're looking for a difference of 6 because it's positive and negative. 2 doesn't go into it, 3 and 9. And these guys have a difference of 6. So we're going to have a 3 and negative 9. So it is factorable, which is nice. So we're going to have s plus 3 and s minus 9 equals 0. Now we can split this up. So s plus 3 equals 0 and s minus 9 equals 0. If we solve each one of these, we get s equals negative 3 and add 9 here, s equals 9. Now, one of these does not work. Which one of these does not work? Well, it's going to be the negative 3 because if we look up here, s is the length of the shorter leg. We cannot have negative length. I'm going to disregard that one. So if I go ahead and write our solution over here, we're going to have the shorter leg, longer leg, and the hypotenuse. So the shorter leg is just s. Longer leg from over here is s plus 3. And the hypotenuse was s plus 6. So if we go ahead and put in our answers here, we have the shorter leg is s is 9. So we have 9. Let's look at the units, feet, so 9 feet. The longer leg is going to be s, which is 9 plus 3, so it's 12 feet. And then the hypotenuse is s plus 6. S is 9 plus 6 is 15 feet. Now, you can make sure that these make sense in terms of the original problem. This is a good way to check. we know the longer leg was 3 feet longer than the shorter leg. And if we look here, 12 is 3 feet longer than 9. And then the hypotenuse is 3 feet longer than the longer leg. 15 is 3 more than 12. So we're just kind of making sure that these make sense. It's really important to do with these kinds of questions because it's really easy to get mixed up when you're doing all of this work. Okay, number 4. Number 4, I will go ahead and type this one up. This one's not quite as long, but we are given the diagonal of a rectangular rug. Measures 15 feet, and one side is 3 feet more than the adjacent side. Find the dimensions of the rug. Now you can see problems asked like this in a slightly different way. Sometimes it'll give you the length and the width. In this case, they told us the side and an adjacent side. Now, first thing I'm going to do is actually draw this one out. Sometimes, again, they'll give you the diagram, sometimes they won't. In this case, it says the diagonal of a rectangular rug. So I'm going to draw a rectangle. And the diagonal, let me see if I can draw this in. That diagonal means the distance going, let me actually put that in a different color. So it's the distance that goes from one corner to the other. And so this diagonal versus the diagonal going this way is exactly the same. So it doesn't matter where we put that. All right, so now if we go ahead and look at this, we have our diagonal. And we know the diagonal measures 15 feet. So this here is 15 feet. Label everything you know. One side, doesn't matter which one, is 3 feet more than the adjacent side. Since it's 3 feet more, I'm going to assume that it's the longer side. And it's 3 feet more than the adjacent side. Now, adjacent means next to, so that would be like this side and this side. So if I call this side X, the side adjacent to it, so either this one on top or this one on the bottom, they're exactly the same because it's a rectangle. One of those, both of those, is 3 feet more than the adjacent. So it's going to be X plus 3. Now, it doesn't matter if you put it up here, if you put it down here, this is still X. These are all, it's a rectangle, so the ones opposite are congruent. They're the same length. So we have 2 different right triangles here. It doesn't matter which one we work with because they're both exactly the same. We have a right triangle, so we can use the Pythagorean theorem. So we're going to have the leg plus the leg squared equals the hypotenuse squared. So we're going to have x squared plus x plus 3 squared equals hypotenuse squared, so 15 squared. Now let's simplify. We're going to have x squared plus x plus 3 times x plus 3 equals 15 squared is 225. Now if we go ahead and multiply this out, we're going to have x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Now I'll combine and then we'll get it equal to 0. So x squared plus x squared is 2x squared. 3x plus 3x is 6x. Plus 9 equals 225. Now I'll go ahead and move this 225 over to get it equal to 0. So we have 2x squared plus 6x. If we go ahead and subtract those two numbers, their opposite signs, we're going to get to negative 216 equals 0. Now, one thing I'm going to do, because again, if you notice, these are all divisible by 2, I'm going to divide them all by 2 so that we have to work with smaller numbers, or we get to work with smaller numbers. Now I'm doing it to every single term, even the 0 on the right, even though it's not going to change it, just so you're in the habit of always doing it to every single term. So we get x squared plus 3x. Half of 216 is 108, so minus 108 equals 0. Now, before we go to the quadratic formula, let's try factoring this. So we want to multiply to negative 108, add up to 3. So we need two numbers with opposite signs that have a difference of 3. So we're going to have 108, 254, still pretty far apart. 3 goes into it. So 3 goes into 90 30 times. 108 is 18 away. So we're going to have 30 plus 6. So 36 because 3 goes into 18 6 times. 4 is going to go into this. Half of 54 is 27. So to find how many times 4 goes into it, you can half and then half again. 5 does not go into it because it ends in an 8. 6 goes into it because 2 and 3 both go into it. So 6, we know 6 times 10 is 60, and 60 to 108 is 48. 6 goes into 60 10 times. 6 goes into 48 8 times. So we have 18. 7, let's see if 7 goes into it. I'll do the same kind of thing. So 7 goes into 70, and then 108 is 38 away. 7 doesn't go into 38, so it doesn't go into this one. There is one way to check to see if 7 goes into a number, but it's really kind of weird, complicated method, so I don't use it. 8 does not go into it because 4 doesn't go into it an even number of times. 9 does go into it, and 9 goes into 90, we know 10 times. From 90 to 108, it's 28. Not 28, wow, 18, sorry. And 9 goes into 90 10 times, 9 goes into 18 2 times. Put those together, we get 12. These guys have a difference of 3. So even though this one took a little bit longer, it is factorable, so it is going to be a little bit nicer than going through and doing the quadratic formula. But it's up to you. You could still get the same answers by doing it with the quadratic formula. So let's go ahead and factor. And for this one, we're going to have a negative 9 and a positive 12. So x minus 9, x plus 12 equals 0. Split this up, we have x minus 9 equals 0, x plus 12 equals 0. And if we solve each one of those, we get x equals 9. And subtract 12, you get x equals negative 12. Now again, x is a length. We cannot have negative length. Disregard the negative one. So x is equal to 9. And if we go ahead and find our dimensions here. So the dimensions, I'm just going to put length and width. Doesn't really matter which you have. Well, let's do this actually. Since it's asking for the dimensions, I'm just going to put the dimensions. So we have x and x plus 3 is our two lengths here, so length and the width. X is 9, and then x plus 3 is going to be 9 plus 3. So our dimensions are going to be 9 feet by 12 feet. So a lot of the times when you're typing in your answers for these, it'll have you put the units, so make sure you pay attention to the units, and it'll have you put maybe the shorter length on the left, the longer length on the right. It'll kind of specify which one should go in which box. So make sure you pay attention to that. All right, let's tackle one more of these problems. And this is one where it's either really nice and you can do it really quickly, or you can go the slightly longer way, which sometimes is something you have to do. So I'll show you both methods. So let me type this one in. All right, so a rectangle has a length of 2 meters less than twice its width. When 5 meters are added to the width, the resulting figure is a square with an area of 144 meters squared. I'll put in that squared once I write this out. Yeah, okay. Find the dimensions of the original rectangle. Oh, is it not going to let me? Oh, there we go. Perfect. All right, so let's do this. Make this smaller. Scoot it down a little bit. And then I'm going to put that square in, so 144 meters squared, because it's an area. So make sure you have that. Okay, so first thing I'm going to do is draw this out. And there are 2 different ways to do this. I'm going to show you both of them, but you do want the drawing for both of them. Okay, so it starts off as a rectangle. So we have a rectangle. Say this is our rectangle. And we know the length. So that's this longer piece here. And it doesn't actually matter which one you put as which. But the length, I will normally do as the longer one, 2 meters less than twice the width. Now, if I call the width W, 2 meters less than twice the width, well, twice the width is 2W. 2 meters less than that means I'm going to subtract 2. So 2W minus 2 is the length. Now, it says when 5 meters are added to the width. This is the part where it gets kind of weird. So we're going to take our rectangle, we're going to add 5 meters to the width. So this is our width here. We're going to extend this 5 meters. And they're telling us that the resulting figure is a square. So I'm going to extend this until this length here is about equal to the length, because then it'll be a square. It's kind of roughly drawn there. I'm going to make this as nice as possible. But we're extending it this way. So we're adding 5 meters going in this direction. Let me actually move that in a little bit, because what we're going to do is I'm going to put our new length. So our new length, or sorry, our new width. So this part right here was W, and now we added 5, so it's going to be W plus 5. Now, 2 ways to do this. This is going to be, we're going to have method number 1 and then method number 2. Method number 1 is going to be a lot easier, in my opinion. Sometimes, so if they don't give you a square as the final figure, you cannot use this. It must be a square. But they tell us that the final figure, so the square, it has an area of 144 meters squared. Now, if you remember, for any kind of square, if I can get this, a square has congruent sides, so all 4 of these are the same length. That's what these tick marks mean. And our area is 144. So if we know all 4 sides are the same, To get area, you multiply the length times the width. Well, if I'm multiplying two numbers together and we end up with 144, and I know those two numbers are the same, I know that each side has to be 12 because it's a square. All four sides are the same. 12 times 12 is 144. Now, this is going to make our life a lot easier because in our square up here, we know that the new width is W plus 5, and the length is 2W minus 2. Now, W should be the same in either case, and I'll show you that by solving both of them, but you only need to solve one of them. If I solve this one here, if I add the 2, we get 14 equals 2W, divide by 2, and 7 equals W. If we do it with this equation, 12 equals W plus 5, subtract 5, you still get W equals 7. Either way, W is equal to 7. That should be the case. And now if we look for the dimensions of the original rectangle, so back to this guy right here, the width was W. So the width, I'll put this up here, is, and this was W. W is 7, so it's 7 meters. The length is 2W minus 2, so 2W minus 2. We actually already figured this out, but if we plug in the 7, 2 times 7 minus 2, 2 times 7 is 14, minus 2 is 12 meters. And we got that over here because we know that that length has to be 12 no matter what. All right, that is kind of the nicer way. That's more of the logic-based way of going through this, looking at the sides and seeing what they have to be. Method 2, what we're going to do is, we know our final shape is a square. Let me draw out our square again. We know the area is 144. I'm going to put that in the middle. We know that the length here is 2W minus 2, and the width is W plus 5. So we're using the same kind of dimensions. The only difference here is I'm not going to just set those equal to 12. I'm going to use the fact that area is equal to length times width. So area is 144. This is equal to the length, 2W minus 2, times the width, which is W plus 5. Now we have to go through and solve this equation. So this method is longer, but if you're not given a square, it's just a rectangle, you have to do this because you don't know that all the sides are congruent if it's not a square. So let's go through this just so you can kind of see it. 2W times W is 2W squared. 2W times 5 is 10W. Negative 2 times W is negative 2W. Negative 2 times 5 is negative 10. I'm going to get it equal to 0, so I'll move this guy over to the right. So we have 0 equals 2W squared. Let's combine these. I forgot about those two, so that'll be an 8W. Let me fix that really fast. And then negative 10 minus 144 is negative 154. Just like we've seen before, these are all divisible by 2. So I'm going to reduce our equation a little bit and divide these all by 2. And I probably won't have room to work this one here, so I'll move it on to a different page. But we're going to have 0 equals W squared plus 4W. And now half of 154, half of 150 is 75. Half of 4 is 2. 75 plus 2 is 77. Now, I'm going to go ahead and try to factor this. So let's see if we can factor it before we go straight to our quadratic formula. And looking at what we got over here for W, it should be doable. We're multiplying to -77, adding to 4. The only things that really go into 77 are 11 and 7. Those have a difference of 4. The 7 is going to be negative. So if I go ahead and factor, we get 0 equals W plus 11 and W minus 7. Let me do this up here. So we have W plus 11 equals 0. And if we subtract 11, we get W equals -11. We do not want negative length. We cannot have this. Now, if we look at our other one, W minus 7 equals 0. Add the 7, we get W equals 7. This is what we want. This is what we got over here doing it in one step because you either had to do one or the other. This one was a lot longer, but sometimes it is necessary. But now we're at the same point where we know what W is. So we know the width is 7 meters. And the length, we plugged in 7 and we got 12 meters. So same thing, you just plug it in up here, which we've already done. So 2 different methods for this problem. If you do method 1, you have to have a square so that you know that all 4 sides are congruent. If not, method 2 is kind of the standard way of doing this problem. If you look at the help me solve this for this one in your homework, it is going to go through this method most likely because this is the way that we're kind of learning to do this stuff with our quadratic equations. But that is it for 11.5. We are now done with all of the sections, and so the only thing left is the final exam.